Hello everyone, this is part 2 of my integration by parts series. This will go through some medium to hard problems, and I'll produce a part 3 video which will go through one hard question. After this video you should be ready to do that. If any of this helps you, please do like and subscribe, as it will really help me in the channel and it will help me reach this content to more people. So let's start with this. We need to make a choice for u and for v dash. So u in this case is going to be cos 3x and v dash will be e to the 2x. So that means I need to differentiate the u to get u dash, which will go to minus 3 sine 3x. And v will be the integration of e to the 2x, which will give us 1/2 e to the 2x. Brilliant. By parts formula, just to remind you, that if we have the integral of u v dash with respect to x, then this will give us uv minus the integral of v u dash dx. So all we need to do is to substitute into here. So there's the original integral at the top. So that's e to the 2x cos 3x dx. And then we've got u and v. So u is cos 3x. V is 1/2 e to the 2x. Then we have minus the integral of v u dash. So remembering v is 1/2 e to the 2x again, and u dash is minus 3 sine 3x. Okay, so let me just simplify what we have here. Just bring the 1/2 up to the front. Got 1/2 e to the 2x cos 3x. Notice in here we've got a negative sign there and a negative sign here, so that's going to go to positive. And we have 1/2 and a 3, which is going to be 3/2 when pulled out of the integral. Inside we'll just be left with e to the 2x times sine 3x dx. Now at this stage is where I would look at this part here and I would think about using by parts again. So I call this repeated by parts. If you ever see sines and cosines within a by parts, what you'll likely be doing is using by parts twice. Because if you remember, when you differentiate sine x, it goes to cos x, and when you differentiate cos x, it goes back to sine x. So it can return. So as you can see, this integral contains sine x, but if I was to do by parts again, then the second integral will contain cos x again. And it should look exactly the same as this one. And at that point, we can actually just use a nice substitution for the integral. We can just call it I. And then when we see it again later, we can also call that one I, which will allow us to rearrange for I and solve the rest of the integral. So I'm just going to work on the bit that's underlined. So what I like to do is just write consider, and then I just do that integral. I'm not even using the 3/2 at this point. I'm just doing what's in the integral. Okay, so very similar choices as last time. We'll make u the sine 3x. V dash will be e to the 2x. We know v because we've done it earlier. And u dash is nice and easy. Bring the 3. Ooh, so you're going to cos. There we go. And so if we write this one out, we need uv, which will be sine 3x times 1/2 e to the 2x. Then we have minus the integral of v u dash. So v again is half e to the 2x, and u dash here is 3 cos 3x dx. Simplify will give us, remember we're starting here, just to write that nicely in one line, gives us half e to the 2x sine 3x. Take away, then we've got, remember it is take away because we've just got a minus sign there, nothing to cancel. We've got 1 half here and a 3, so that's minus 3 halves. The integral, then we've got e to the 2x times cos 3x dx. What you should notice now is we've ended up with that integral again. Okay? So the trick that I'm going to do is you see the bit that I've underlined here as e to the 2x sine 3x. We've worked that out here. So then what we can do is just substitute all of that here. Okay? And that's what I'm going to do. So I don't need all of this working out anymore. So I'm going to rub it out just to create some more space. Okay, and it stops all that confusion. So that is simply going to go there. Okay? So let me write all of that out. And I'm actually going to write this again, remember, because that's what we was starting with originally. So we've got the integral of e to the 2x cos 3x dx equals, so we're writing this, we've got half e to the 2x cos 3x, and then it's plus 3 halves, and that is where I sub in the integral that I worked out. So that's a half e to the power of 2x sine 3x. Okay, and then we've got minus 3 halves. Remember, this is still within the bracket. Integral e to the 2x cos 3x dx, and that's the end of the bracket. And then I can just go ahead and simplify this. I'm still going to write it out in full. When you get a bit better at this, then you can probably save some steps. So what do we have? We've got half e to the 2x again, cos 3x. Now, multiplying the 3 over 2 by the whole bracket is going to give us plus 3 over 4 e to the 2x sine 3x. Then we've got this 3 over 2 multiplied by minus 3 over 2 here. Let me just move this out of the way so we don't need it anymore. So that's going to give us minus 9 over 4 for this bit, and then we've got this integral, which I'll just write. And what you should notice is, if I make this really clear, that is exactly the same as that. So you've got the repeated integral come back. So what I'm going to do is just replace this with the letter I, and also this, because it's the same thing. So effectively we're going to let I equal the integral of e to the 2x cos 3x dx. Basically like that. Which will allow me to get rid of that and just call it I. And to also get rid of this one and just call that I. Okay. Great. And then I can rearrange for I. So let me bring 9 over 4i to the left side. So adding those up gives us 13 over 4i. And then we have everything else that we see on the right. And then plus 3 3/4 e to 2x sine 3x. So I just had to move that out of the way. Okay. Then we can times everything by 4 and then divide everything by 13. Or we can do it in one step and just times everything by 4/13. So let me do the 4 bit first. So if I times the half by 4, that's going to be 2. And if I times this by 4, it will just be 3, which gets rid of that. Then divide everything by the 13. It gives us I. And if you remember, we set I as being the integral that we did originally, which is e to the 2x cos 3x dx, and we have our answer here, which I'm now just going to make a little bit simpler. So I'll bring out e to the 2x over 13, and that will leave me with 2 cos 3x and 3 sine 3x. Don't forget at this stage to add the plus c on the end. I didn't do that earlier just because I didn't want to have to keep rearranging and moving around a c as well. So that will be the final answer to this question. It's really, really handy to be able to use I when doing by parts. Okay, this is the next one. So we've got x squared ln x. So let's see what happens if I do this. If I do it this way, I would have to differentiate the u, which would give me 2x. But then again, imagine I'd end up with that in my second integral. Not quite sure what's happened with the pen here. There we go, sorry about that. Right, v here would be the integral of ln x with respect to x, which we can work out, but this would still need to use by parts twice. So there's option 1. Now option 2, if we did instead u as ln x, then u dash would be 1 over x. That would mean v dash here would be x squared, and v would be x cubed over 3. The bottom one seems the easier choice. However, you're still going to end up with x's in the next integral. But we'll see how this happens anyway. We'll see what happens. Right, so if I do option 1 first, that would be, let me write the original integral, x squared ln x dx. So the first thing we need to remember is uv, so that would be x squared times by the integral of ln x. Now the trick for working that out is to write that as being ln x times by 1, like that. And then we would let u equal the ln x, meaning u dash is 1 over x, and v dash is 1, v being x. This then goes to x ln x minus the integral of v u dash, which is these two times together. So x times 1 over x will just give you 1. And the integral of 1 is just x. And so that is the answer to v. So if I rewrite that here, Don't know why it doesn't want to rub out. Never mind. Okay, so that can be x ln x minus x. Great, I don't need this anymore. So that can go straight in then. So going back down here, that's our u. We need our v. There it is. Minus the integral, and then we've got vu dash. V is x ln x minus x, and u dash is 2x dx. Okay, simplifying, it's going to give us x cubed ln x, take away x squared. Then we've got minus the integral, and we have a 2x squared ln x. Multiplying that is minus 2x squared dx. Okay, now noticing, just like what happened last time, we have x squared ln x here, and you can almost see that popping up there apart from that 2. So if I do a bit of moving around with this, I can write that as I, and then I can write this bit as I later. And we can use that little trick. So, simplify. X cubed ln x minus x squared. Then I'm just going to pull that 2 out. Okay. Oh, tell you what I'll do first actually. What I'll do first is I'm going to split this into 2 integrals first. So that'll be minus the integral of 2x squared ln x dx. And then with there being 2 minus signs here, I can write this one as plus the integral of 2x squared dx. And then if I just pull out that 2 there, then you should notice that this is the same as that there. So what I will do is just drop that integral down like that. Then I'm going to make this very clear that this is our I, and also this is I. So then I can rewrite that below. So it's going to be I equals x cubed ln x minus x squared. And then here we've got minus I, and then plus this. Let's just perform that integration. So raise the power by 1, divide by the new power. It's going to give us 2/3 x cubed. Okay. Then I'm going to move this I onto the left, which is going to be 2i. And I'm also going to simplify a little bit. So you can see these two like terms. Hang on. I forgot to write cubed here. Sorry about that, guys. If you remember x squared times x, it should be x cubed. I don't know why I've done that. There we go. If any time I do make an error, please do let me know, because it does happen. So you should see here, these are like terms here. Okay, so that's minus 1 plus 2/3, or just minus 1/3 x cubed. Then I can divide by this 2 here, which would just give me I to be, pen's bugging out, x cubed over 2 ln x, divide by 2 again, remember, so we've got minus 1/6 x cubed. And then finally we can just factor out the x cubed. Okay, and that will be our answer there. Remember, I was the integral, which is the original integral, and so that is the answer. Okay. Right, this one's next. A lot of people think this one's absolutely disgusting. It doesn't look like a by parts question, but it is, because you can rewrite this as being ln x times ln x, but that would then mean that one of these needs to be differentiated, and one needs to be integrated. So they're both ln x anyway, so we have to just write it like this. U dash, remember we know the differentiation of ln x is 1 over x, and from earlier you can get the integration of ln x with respect to x, which was x ln x minus x. Remember, if you're unsure on that, just rewrite it as ln x times by 1, and ln x will be u and 1 will be v dash. But I'm not doing that again since we did it earlier. Okay? Great. So there we go. Let's put it into by parts. So that would be the integral of ln x all squared. We'll go to, firstly, uv. So that's ln x times x ln x minus x. Take away the integral of v u dash. This is v, and u dash is 1 over x. So that's nice because it will just cancel out the x's, leaving us with, I'll just rewrite, expand that like that, and then we've got minus x ln x. Here we've got the negative sign still, integral, got ln x, then this x when cancelled will be a minus 1 dx, like that. Okay. Let's just finish this off. Then, if you think you've got, take away the integral of ln x with respect to x, which we already know from earlier here. And also two negative signs with a 1, giving us plus the integral of 1 with respect to x. So we already know that, and this one's easy, it just goes to x, so that's cool. And so finally this will be integral of ln x, we have it there. And integral of 1 is just going to be x, remember. I could write plus c at this stage, but I'm not going to yet. Try and do some simplifying. So that's minus x ln x, which you can actually see there. Let me just rewrite that so it looks the same. And then you've got plus x from that bit, and then plus x there. Let's put both of these bits together. So that's minus 2 minus 2x ln x, and then here you've got plus 2x on the end. And now I'll add plus c. And that's the answer. We could, if you wanted to, you could factorise out x if you wanted. which gives you a function like this. It's a nice way of writing it. Okay, so that's the answer factorised. Yeah, just earlier, if you remember, we had another option here for this question. I might have a look at doing the other option in a later video, but I'll come back to that. Last question of today will be this one. So this one is a bit strange. Not a lot of students are used to seeing this sort of integral for by parts. So we'll have a look at it. Now the trick here is to let u be the inverse trig. So that would be the inverse tan of x. Okay. And then v dash will be the x. Not quite sure what's going on with my pen again. Hopefully it'll come back to life in a minute. There we go. So v dash will be the x. Integrating that gives you x squared over 2. And if you differentiate the inverse tan of x, it will actually give you 1 over 1 plus x squared. Okay? If you're unsure of where that's come from, it comes from performing implicit differentiation. Which I will go through in a separate video, which I'll link here. Okay? And this will be one of the questions in that video. So if you're unsure, then look there. Right, let's carry on. So let's do the integral. This will be uv, which is the inverse tan of x, times x squared over 2. Take away the integral of v u dash. There's v again. U dash is 1 over 1 plus x squared dx. Great. So, I'm just rewriting and simplifying. I can take that half out at the front, like that, and then I just end up with x squared, let me write this a bit different, x squared over 1 plus x squared. Now I understand this might look a bit weird, and if you look at the denominator, if you had that actually at the top, then that could be split nicely into two fractions. This can still be split into two fractions, but it's just a little bit weird in how we do it. I'll show you what I mean. So I'll write that the same, but then this integral, we're just going to move it around a little bit. So the denominator has to stay like that, but I could change the numerator to being this. If I wrote 1 plus x squared there, when I only started with x squared, then just take away 1 at the end. And that will allow me to split this up into two fractions now. So 1 plus x squared over 1 plus x squared is 1, and then minus 1 over 1 plus x squared. There we go. So that's minus a half, then we have the integral of 1 with respect to x, just splitting these up. Two negative signs here will make a positive, so that would be plus a half, and then we have that there. Now, 1 goes to just x, so that's going to be x over 2, which is lovely. Then we've got the half here on this integral, but if you have a look at that integral, okay, we've actually done that earlier, because effectively, if u dash is this, then when we integrate u dash, it goes to u, which is inverse tan of x. So this just goes to the inverse tan of x. Brilliant. So that's plus 1/2, and then it will just be the inverse tan of x. And at this stage we could write plus c, but I won't, because I'm still performing my integration. That's the original. Okay. Let's see if there's anything else I want to do. Probably just take out that inverse tan of x. I'll just put plus c there for now. So let's take that out. Inverse tan of x. I can see all the 2's at the bottom as well. Let's do that. And then let's just write what we have left. So x squared. Then we've got minus x there. And then plus 1. Oh, sorry. Don't listen to me. This one doesn't contain an inverse tan, does it? So actually we'll just write plus 1/2 there. No, plus 1. There we go. Now, I'll probably make that look a little bit nicer. So I'll leave it as a final answer. Okay. So there you go. There's 4 integrations by parts. If you found this video helpful, please like and subscribe. My next part will be going through one very, very difficult integration by parts question. If there's anything you want to see on the channel, then please leave me a comment and I'll be more than happy to go through it. Thank you very much and have a nice day.